Okay, guys, let's talk about pedigrees and karyotypes today. These are pretty easy things to grasp, so I wanted to go ahead and just put them on the same video. Now, a pedigree is a family chart that shows the passing down of traits. So instead of just looking at like a mom and a dad and their offspring, now we can look at big families. We can look over several generations of the passing down of traits. Now, there's a couple rules for it. First of all, squares means that was a boy, circles means it was a girl, and if it's shaded and it has the trait. So if I look at this first pedigree, first of all, you can notice that there's Roman numerals. That's just talking about generations, so generation 1, generation 2. And let's say this trait was recessive for blue eyes, okay? So if I just look at it first I can see that this man and woman got married. That's what that line means. And when you have the line coming down from the middle, that means they had these children. So they had a boy, and a girl. Now, if you notice, one of these boys right here, he's shaded in. That means he has that recessive trait. Well, if he has a recessive trait, then I know his genotype. I know he was 2 little letters. All right, so let's think back through. If that person has 2 little letters, where did they come from? They came from his parents. So that means this mom gave him a little letter and this dad gave him a little letter. But they're not shaded in. That means they show the dominant trait. And if I have a dominant trait, I have to have what? A capital letter. So I know both of his parents were heterozygous because they didn't show the trait, but he did. Now, if I look at his siblings, they're not shaded in, so I know they have to have at least a big A. Do I know the other letter? I don't, because they could have either been 2 big A's, one from dad, one from mom, or they could have gotten a big letter from one of the parents and a little letter from the other. But that's kind of how you interpret a pedigree, is you just see who has the trait, and then you can kind of work backwards and forwards as far as what their genotypes are. So let's look at this one. Now we're looking at 3 generations. Let's go ahead and use the same thing. Let's say the trait is recessive for blue eyes. All right, so I can see that this mom, or the grandma, had blue eyes, and then this grandson all the way down here. Well, if they have the recessive trait, what are their genotypes? Little a, little a, little a, little a. All right, so we can kind of do this one or 2 ways. We can either work down from grandma or work up from this kid. Let's work up from the boy, because that's what we did on the last pedigree. If this boy has 2 little letters, that means he got 1 from his mom, he got 1 from his dad. But neither one of them are shaded in, so that means they are both heterozygous for that trait. And then his sister, since she has a big letter, will be A with a dash, because I don't know if she got 2 big A's, one from each parent, or a big A and a little a, one from the other parent. All right, so now I can go up here. I know this grandma, right here, these 2 little A's, she had 2 little letters. That means she could only give little letters. So even though this circle right here is not shaded, I know they have to be heterozygous because they got the little letter from their mom up here, and then the big letter from their dad. The only thing is I don't know what the dad is because neither of the children that these 2 had, the 2 daughters, have a recessive trait, so I know he has to be just a big with a dash. But that's really how you interpret pedigrees. It's just like doing Punnett squares. Without the Punnett square, you just kind of start looking to see who has the trait and then figuring out where that trait got passed down. All right, then the next idea is a karyotype. These are pretty interesting. A karyotype is a picture of a person's chromosomes, which is crazy that, that's something that we can do. It's a genetic counseling kind of situation. What they do is they take a picture at a person's most condensed state, like their DNA. So that'd be during mitosis, because remember, during interphase and cytokinesis, your DNA is in that chromatin state. That's not going to show you a lot. But if I take it at the most condensed state, then I can actually see the chromosomes. I can see those sticks. And really what we use a karyotype for is to see if somebody has a genetic disorder. So the things that we do know is that everybody should have 46 chromosomes. Those 46 chromosomes are arranged into pairs. The first 22 pairs are autosomes. Remember, those are the traits that just code for the organism or for the person. And then that 23rd pair is going to code for the sex of that organism, if it's boy or girl. Now, what they do is once they take that picture of your chromosomes, they group them by size. So I didn't do a whole 423 pair. I just wanted to give you an example. So the biggest pair, that's chromosome number 1. And then these barcodes that you can see on here, those are actually really cool. You can see those on real karyotypes if you go Google one. But those bandings, that's literally where you can see a person's genes, which is just cool. And so then there's your number 2 pair. Again, same size, same genes, 3, 4, etc., until you get all the way down. Because remember, they're arranged by size. So by the time you get to the 21st and the 22nd pair, they're really tiny. Now, to determine the sex, this one right here, this would be a boy. Because my X's are big, but my Y's are small. So if this were a girl, I'd have 2 of the same size. I would have XX. But this one right here is a boy. But like I said, we use these karyotypes to figure out genetic disorders. And so one genetic disorder I think we're all familiar with or we've heard about is Down syndrome. Down syndrome's real scientific name is called trisomy 21, which makes sense because we can figure that out. Tri means 3. Somy is talking about chromosomes. And then 21 means it's the 21st pair. And so if you have an individual and you suspect that they have Down syndrome, they can do this karyotype. They can grab their chromosomes and take a picture and then arrange them by size. So look, you can see number 1, they're the same size. Everything looks good. They're in pairs, 2, 3, ... But when you get here to this 21st pair, you can see that I have 3 chromosomes at that 21st pair. When you have 3 chromosomes at the 21st pair, that's how we diagnose Down syndrome. Because when a person has Down syndrome, they tend to have all the same kind of phenotypic qualities. You know, they're usually shorter in stature, shorter digits, broader chest, etc. But that's how a hospital or a doctor will figure out if a person has a genetic disorder or not, is by looking at their chromosomes and seeing if there are extra or if you don't have enough at a particular pair, right? Like another type of genetic disorder would be only having 1, like maybe at chromosome number 5. You're supposed to have 2 chromosomes, but this one isn't there. And so a person missing a chromosome will be diagnosed with a different genetic disorder. When you guys go do your homework, you'll get to see a couple different kinds of genetic disorders and what they look like on a karyotype. So anyway, 2 pretty different topics, but easy enough to explain. Pedigrees show you traits being passed down. Again, we can go through that. Karyotypes show you your chromosomes in the most condensed state, and we can figure out if you have any type of genetic disorder based on this. Okay, I hope that helps.